Great. Welcome, everyone. Before we get started, I'd just like to get a show of hands of how many people in the room are actively working on a water supply project with EWB USA. Cool. So hopefully this will be pretty applicable to the work you're doing. We're focusing on the very specific topic of mapping. And John and I are both going to do this. I'll give more of kind of the background. The presentation is really in two parts. One is just kind of the nuts and bolts and the main components of mapping as it relates to water supply projects. And then the last part is more about some specific tools that you can use as you are either doing the mapping or collecting data that is useful to have spatially referenced and added to your maps. So the outline here, the first couple, these are just the description of the slides we'll be going through. Again, I'm going to start off just kind of revisiting why we even do mapping, and then we're going to go through the actual standards, accuracy and scale that you should be using, the different sources that you can refer to for mapping, getting your base maps, and then that last part again are the different types of tools to use for mapping. And then there's also going to be a great useful slide of links to get different data sources. So project management, where does mapping fit within any project? There's some component of mapping within every project. And if you look at this slide here, it talks about just any kind of project, all the different components. You have the anthropological, that community assessment, you have that technical assessment, you have a financial piece, and you have that administrative portion. And any project is going to have those parts. And what although it's all really important in doing any project, and then there's certain nuances that are especially critical for international community development, we're talking about this little piece of mapping that's most applicable in that technical aspect. Although I would like to highlight that, like any international development project, you always get in trouble if you just focus on the technical without the community side in every step. And even in mapping, there is a really integral community portion to it. And I would say that mapping can be a really useful tool. Even that circle should almost be drawn a little bigger into the anthropology and community and in that a community assessment process. So we're going to try and touch on all of that today. So first off, why do we use maps? Why do people use maps? Anyone recognize this map?
That's where we are.
Yeah, you've looked at a map before. If you knew right away, you knew this was the map where we are. So why do we use maps? No ideas? Spatial representation of data, exactly. Spoken like an engineer. No other ideas.
Because if we have met, we know everything about the area.
Yeah, everything. Yes. So if we do a map, then we're done.
To learn about a place that we haven't been yet.
Yeah, so to use it before you even travel somewhere to kind of orient yourself before you've even been there.
To simulate our world as it could be.
Yeah, to see the potential. Mm-hmm.
Maps go beyond languages.
Great, excellent point.
You get from point A to point B.
Yes, that's true too.
We learn from the land where we're going to build, so we know the characteristics of that land, and we can actually build our design based using those characteristics as constraints.
Exactly, which is a key point to kind of have a perspective around, is that a map isn't simply to take data and information or design and plot it somewhere. It can actually be used to build your design. In some ways, it's the base of your design. It's what shapes the direction you even go, especially with the water supply. Are you going to even think about a gravity-fed system or not? That map is what can help you build that design. So here's a summary of the different things we came up with, which I think number one is exactly what was said first. Spatially oriented data can be visualized. John came up with that one. Engineer thing. But just looking at different data attributes and seeing them spatially can allow you to do different kind of analyses. Different data types. It just allows that problem solving. It's also a useful tool for consensus building, that tool to help communicate certain ideas. And then it allows you to tie, I was talking about you use the maps to start and then build up, but it's also that important piece of when you're putting together your construction drawings, which I just gave a talk on, so important to tie those facilities to actually on-the-ground features so that you know where to build something. And so it's really important to have that link as well. And then it's just a great way to share information with others, even beyond the builders or the designers, for the community, for donors, for a lot of different stakeholders in the project. All right, and then this is, the next couple slides are just talking about the specific type of maps that are most important in water supply projects. So any water supply project is going to have some kind of base map. And even if it's a point of use biosand filter project where you're not actually laying out a whole system, it's still really important to have that base map to understand that community and how it's oriented and what kind of, even that decision with a point of use, treatment unit. Does it make more sense to put them with clusters of homes versus individual homes based on that baseline map that shows the household distribution in your community? So no matter what kind of water supply project, there should be that base map. No way around it. And some key features are highlighted here that you should be striving for in that base map, including the community boundaries. That's a really important one that can be kind of hard to figure out, but it's worth it to figure it out so that you can understand, are you looking at spring sources that are maybe outside of the community boundary? And if so, what are the implications of that decision? And then different, if it's not communal land, what kind of permissions do you have to have even for a tank or pipeline or whatever it may be? Then the topography and land use is really important. The topography, of course, if you're hopefully considering some sort of gravity-fed option to avoid the operational element of any kind of pump, you need to know that elevation information. And so starting with the basic topography might be enough for your whole design, but it at least can help orient you and know how to follow up surveying that you might need. It identifies the physical and natural resources. On a map, you can kind of identify what are the potential water sources that you might have, what are the other features that you might need to consider, whether there's existing infrastructure and where that infrastructure is and how your system will tie into it or work with it or around it or avoid it. And then the first point I was making here is just that level of service. What's most applicable? Household, community scale, is it a shared tap? What's that overall distribution? So those are some key features. And this is an example of the next slide. On my screen, I could see it. Yep.
Sorry, projections needs out of focus, which is very important in displaying maps.
Oh, okay.
Is there a way to
Help the focus on this? Is there a...
There you go, perfect.
Thank you. It looks really clear on my screen. Thank you very much. And so some features that I especially like about this one is the community boundary is actually shown. This one has the system layout over it, but it clearly shows the topography and the satellite imagery. There's a clear legend that shows what all the different features are, all the key buildings, all the roads, pathways, and everything that applies, which actually, there is a scale. Yes. There is. Do you see it? Okay. And a north arrow. Yes. All these great features that are so often missed. And so basically, through this presentation, you're going to learn how to make a beautiful map like that. So that's the baseline map that any water system needs. The other kind of map that I think applies to water supply system that might extend beyond the system itself is the watershed, the map of the watershed or that drainage area. So how many people on your water supply project have mapped out the watershed? Yay, 2 people. That's better than none. And so this is something that I'm personally pretty passionate about just based on my own experience. I was in the Peace Corps in Honduras for a couple years, and I was getting my master's and wrote a whole thesis about assessing the sustainability of the different water sources by looking at some really simple characteristics in the watershed to know if it's a sustainable source or not. And so I think that's another really important thing that I would love to see EWB USA projects doing a little bit more of, because you can learn so much more about the flow and the quality of a potential source if you understand what's feeding into it, and you can kind of then understand how that might vary throughout the year. So this is an example of one of the watersheds that I looked at in Honduras. Agua Caliente is the name, and I'm not supposed to move in front of the screen. Hopefully you see the blue line where it's the water source, and the base of that's the source. And you know that community map is off the screen, it's something else. And this part usually gets ignored. You walk to the source, you collect a flow sample, water quality sample, you look around and you see, oh, there are trees. And this map show, yeah, there's lots of trees right around there. I think a sample was collected, pretty clean water, decent flow. Project was built, pretty big project. But there's sediment problems. There's sediment problems in this water system, and they actually need a whole new system because the source isn't good because of sediment problems. Does anyone see any, maybe the resolution's not clear enough to see, but could you look at that map? Anyone experience looking at like a watershed and see what could potentially be problems? Robert?
Well, yeah, you can see the browner areas and also the clear areas.
Right.
It's going to be very susceptible to impact separation of the soil by rain.
Mm-hmm.
And then runoff that's going to come right to your source.
Right. And Kelly, did you have?
Oh, I think there's a road or a trail right there.
That actually is the big thing. It's really hard to see. You're in the front row. Maybe you have a better view. But the water course extends higher up, and there's actually a dirt road that crosses it. And the other thing that's not shown here is that where it is really deforested, those are agricultural fields where there's absolutely zero best management practices going on, not even contour farming or anything, and it's really steeply sloped. The topography is not shown, but it's really steeply sloped. So it's an obvious problem that if you just take the time to map that watershed and kind of look at it, you would be able to know that. And so here are just the tool that I came up with, and the things that I think you can look for in the watershed map is you can easily see the slope, general sense of land use, and then sometimes you can see or then ask follow-up questions to determine if deforestation is active, if there's cattle, if there's farm fields. If so, ask the farmers if they're using chemicals in any way, if there's homes and roads. If you just look at those 7 things in my experience, just those 7 things in a simple map, you can learn so much about that long-term water source, the sustainability of that source. All right.
Well, just as an introduction, my history is I grew up in Phoenix, in Arizona, and you need standards when you do almost anything. And how many people here know how long a foot is? Well, how many people know that the length of a foot in Arizona is different than the length of a foot in Colorado or Massachusetts? All right. So having standards and knowing what is used in commonly available areas is a key to doing your project. Everybody knows if they're using a GPS, you know what Latin long is. But if I gave you the Latin long of 2 different spots and asked you to figure it out and tell me the distance of it between the 2 areas, you can't use Pythagoras on it. So it's common for most engineers to create maps in a flat plane and project it on the earth, and then you slice up the world into sections. And for example, most satellite information is produced in what's also called a universe transcrater grid system, which blocks up the area into rectangular blocks that can be placed on a flat map. In addition to that, another standard that's common is a world geodetic system for elevation. So not everybody uses the same standard for what the elevation is. Even in the United States, there's frequently 2 different standards, and they can be often differences, at least in a lot of areas, like 2 or 3 or maybe even 10 feet, depending on what standard you're using. So adopting of the common standard in the country you're working in is a way to proceed. The next thing that's important to think about in maps is the accuracy of the map and the scale of the map. If you attend Kelly's last thing on drawings, sometimes if you have a very large drawing that covers, then you use a small scale to cover a large area. But if you want to deal with a very small area, then you have to use a much smaller scale. If you grab a USGS map or a similar from a foreign country and blow that up you just can't assume that the contours that are on that map are valid just because you blew it up and you interpolated the distances between those contours. So accuracy is a very significant issue. The Asiana flight in San Francisco a year ago last July happened to come in about 3 or 4 meters too low, and so there was a loss of 3 lives, at least 2 to the aircraft, and 200 people injured just because a problem in accuracy of how high the pilot thought he was coming in. Now, in a water system, if your system that you're using to determine the elevation is off by 10 meters, that's an equivalent of about 14 psi in water pressure. So if you're going to provide a house with 14 psi of water pressure, and your contours are off in terms of locating the house with respect to the tank by 10 meters, plus or minus, actually you'd have water running from the tank not to the house, but or the house back to the tank. So having good accuracy is a key element. When I talk about accuracy, accuracy as I'm describing it is how close it is to the true value of something. So for different maps, you need different scales. And there's no reason to put a lot of money into developing a lot of information for a very large scale map, where it covers a large area, when you don't need that detail of information. The key drawings that you need in a set are location maps that might cover a very large area, a vicinity map, community plan, waterline plan. So those are different scale factors that you might consider in developing how to map or how to prepare different drawings. I will comment that for waterline plans, and if you're going to carry it into the field, the 11 by 17 size drawings are fairly handy. You can open them up and they don't get wind blown, and you can stuff them into a day pack, and they're rather handy to operate. If you're going to have a community input and you want to lay out a large drawing, such as the one that's on the table up here, then it's better to have a drawing that's either 22 by 34 or 34 by 36 or as large as you can print. Here's an example of the amount of area that's covered by different scales of drawings. We just picked this map off of, actually got it from the University of Texas Library, and sort of scaled out the areas that we needed to do a waterline project. You can see the watershed map can be fairly large, cover a large area. Vicinity map a little smaller. And for waterline plans, you need more of the smaller drawings to cover a smaller area. Well, where do you start? Well, I guess my comment is don't reinvent the wheel. If there's something available for free, try and get that first. If there's something that's inexpensive, well, then that might be worthwhile. And some of the most expensive stuff, leave till later and only use that for the most detailed areas you need. The free maps. You can get a lot of topography, where schools and churches are, graveyards, communities, even protected areas. You know, we were working on the Hopi Reservation, and we could locate, you know, where their burial grounds were, which something, you know, you don't see when you're walking over the ground. And some of those areas are important just to know in a general area, because you don't want to start running water lines through cemeteries or burial grounds. I will tell you that for sure. Sources of data, and there's a extensive list of links at the back, so I won't enumerate them all, but there's an unbelievable amount of free data out there that you can get on almost everything. I mean, if you want to know where earthquakes are, see if they're in your region, then there's sources for that. Well, let's move into the next thing. It's pretty good information, and it's not too expensive. The maps that you see here in the exhibit are also laid out on the table. Our chapter got from a company called MapMarket, which is a company that gets satellite imagery and data from different locations and sells it. So anyone here can go onto their website, define an area by latitude and longitude by the upper left and lower right-hand corner, and get an estimate on how you get a fairly inexpensive mapping on a fairly large area at very inexpensive. In fact, the area is so much larger than your project area that because there's a minimum cost of so many dollars, that it's really helpful. A key item in in imagery is what's called pixel resolution. A pixel is the size of the element that the camera picks up, or the sensing engine picks up out of the satellite. If you have a pixel size of 0.7 meters, like the photo is that's on the table or on the picture, that means that if you have a truck sitting on a road or something like that, and it's a red truck on a white road or something, you can pick it up fairly easily and identify it. If you have a spring box the size of this table, even though it's concrete, white, and a green area, it's too small for the imagery to pick up at that pixel size. So at different prices, you can get different pixel resolutions or sharpness in your photo. And as you get these large files, in fact, the one we got was about 500 megabytes just for imagery. The sharpness you get depends on the pixel resolution you order. You can get it in color, and that's very handy because most people can relate to color a lot better. You can also get it in infrared, which is a false color, and that color will show wet spots differently than dry spots, so that locations of stream beds or where you might have a possible spring location is more evident if you get infrared photography. Or in the case of black and white, the nature of black and white is to get a sharper resolution of the different colors. As good as it is, though, you're not going to pick up a grass hut in the middle of a straw field of the same color. So that's the other thing that you get from satellite imagery are elevation models. An elevation model is built by the satellite establishing posts in a grid form. And you can order this elevation model with posts at different grid spacings. So it's a corner every, in our case, it was every 30 meters or every 100 feet. Well, with a post spacing of every 100 feet, it's easy to miss a channel that might be 20 feet deep and 20 feet wide that you can't jump across, and it appears in your photo, but the contours don't pick up that level of information. In the lower right-hand corner of the picture, you see the numbers northings and eastings. Those are the coordinates under the UTM system that is commonly used for doing a mapping system. If you're doing mapping in a CAD system, computer-aided design systems like AutoCAD or Bentley, MicroStation, and now even Google is going 3D. You can use, it's good to follow the northing and easting system to locate things. I also mentioned about elevation models. The cheap model is what's called a digital elevation model. And the satellite just hits the top of whatever's there. If you have a large building, then it reports the elevation of the top of the building. If you have an area with a lot of tree cover, then it's just the height of the trees. For a little bit more money, you can ask them to generate what's called a digital terrain model, which is then adjusted so that it tells you the elevation of the ground. For our particular site in Ecuador, the buildings are not large and there's not a lot of trees, and so the elevation model did everything we had. And we got essentially 4-meter contour lines. Probably the most expensive way to go is to go to aerial mapping. And I think if you take a look on the previous slide, it said uncontrolled in the bottom of the slide. Well, what uncontrolled means is that's just the elevation the satellite thinks the ground is. So it hasn't been ground truth to the real accuracy of the ground. So if you want a more accurate model, then you have to drape those elevations and that imagery to what the true coordinates are on the ground and the true elevation at specific points. When you do conventional aerial mapping, first thing you do is go out with a surveying equipment and establish points that can be seen in the aerial photography of what the horizontal coordinates are and the true elevations are. And then that aerial mapping is then rectified to those points so that you get a much more accurate thing with controls of. It's post-processed. You can get imagery from aerial photography that will be at least down to the order that you can see something that with a half a foot in size. Aerial photography can then put in what's called break lines that show where the bottom of the stream is or where the edge of a road is or a road bank or something like that. Then the most expensive at all is field topography. And you still have to start with some control points so that what you map in the field is related to something. And hopefully everything gets related to the same system that's used in the rest of the country in terms of elevation. There are survey-grade GPS units that you see surveyors with, which are expensive, and then it takes special software to do the post-processing, and it can get fairly accurate in terms of very accurate down to 2 or 3 millimeters. The more conventional ones use a transitor, rod, tape measure, hand level. The Garmin GPS unit has a system that includes a barometer in it for at least this model, and that adds an additional level out. The iPhone, you can download a $2 app on your iPhone that does almost everything that the Garmin does, although it's hard on the battery. And I found very handy is a camera that has GPS information associated with it.
Yeah, one comment just looking at the cost for those different options. I don't know, I think some chapters I've talked to when you say you could buy some maps that get you pretty good data that you could, that in your case you were able to do the design, most of it off the 4-meter contour lines. A couple $1,000s is a lot to spend on maps. But when you consider that the alternative is for a few people to fly at a cost of like $500 to $1,000 per person, if not more, it really can be a very cost-effective option, even though that sticker price of the map might feel like a lot. So it's just, I think, something to consider, which is probably why some of those surveying tools, even the cheap ones, are still on the really expensive option. Because when you consider a whole trip around it, it's quite expensive to collect that data. So this is the start of the second part of the presentation, where we're going to get into a little bit more detail on some of the tools to build that map. So assuming that you have some base map that you got, that you're not creating on its own, there's always some additional data that you're spatially referencing and putting on a map. And there's 3 different types of tools we'll talk about. One is community mapping exercises that you can do, and then also just surveying, walking around and collecting data and then putting it to a GPS location to put on your map. And then lastly, going into just a little bit more detail about the different surveying techniques and tools that you could use. So this first one is on community mapping, and this is actually a video we'll give a try of. That was taken with John's chapter, Denver Professionals in Ecuador. Like he mentioned, they brought a big map and put it out for the community to kind of all look at and help engage them in understanding and assessing the community. Do you have anything to add before I hit play?
¿Comienza o no? ¿Y? No. ¿Chipe? ¿Quiere escribirla?
Sí, está bien.
Ok, ¿y cuál casa? ¿Ne? ¿Y tú no tienes agua ahora mismo?
No tengo yo.
Ya. Ok.
Sí. Sí.
Muy bien. Entonces... Caimos. Sí, sí. Ah, sí. Ok. ¿Cómo se llama, señor? Tú aquí.
Acá hay
Tú aquí. Yo estoy acá. ¿Está bien?
Sí.
Ya. Nosotros estamos en tu casa, ¿sí? Muy cerca de tu casa, ¿sí?
Sí, ahí lo que estaba sentado.
Sí, arriba. ¿Tú tienes un grifo? No. No hay nada ya.
No comer nada.
Ok, ya.
Says I know this is very close to my house.
Yeah. Is that a poem about gringos?
No, that's the definition for faucet.
Oh,
Hose bin.
okay.
Hose bin.
And this is a picture of a community mapping exercise in kind of a different form. I think that's one way to just get people talking and oriented. But this is actually from a project that I traveled with the team on in Peru with Rachel here, where we did a community mapping exercise where all we did was bring big sheet of white paper and some markers and have them sketch out the community. And, it serves one purpose, I think, when you first show up at a community, just to get oriented, to kind of even know where you would do your surveying. And I know from my Peace Corps experience, whenever I did this with the community, I was always shocked at how good they were at mapping out their community. And it makes some sense because it's their whole world in a lot of cases. They've rarely left that community and those boundaries. And so they know so well where everything is. And there are some good artists in the community that are able to really sketch it out in a meaningful way. The other thing that I think that can happen is you learn a little bit more about what the community values. And so in this case in Peru, we didn't give much instruction, just draw your community. And I was expecting at least them to draw out like the streets, the houses, where the church was, the community center, and all of that stuff. And the map that they drew was just a circle for town center. And they spent all their time mapping out the different farm fields that were part of their entire district and the different water sources and all these other features that we recognized were true assets to them and what they valued and were important to show that really, I think, kind of shifted my mindset around the community. And we would have never seen that without that mapping exercise. So I think it can be a really powerful tool in that assessment data collection. The other key thing to collect spatially relevant information, like if you're doing a water supply system and you want to know water quality and pressures at different houses, you're actually going around and doing surveying at each house and recording that GPS location so you can later add it and get a better understanding of your project. And in this slide here, I recognize you probably can't read anything, but the point is that you can get this example of the slide and John and I could email, but this is a decent questionnaire that you could use for technical data collection, primarily for water supply systems, that you could use in your overall community assessment. And generally, it relates to maps and your ability to then put it on a map later, that information.
And just adding one item, one of the other discussions was there's a new form out called the 900 series, and they're talking about establishing baseline information. So what the questionnaire does include is baseline information like how far do you walk for water, is the water good or not, do you have a tap, and a bunch of questionnaires that the questionnaires essentially provide a baseline at the beginning of a project. So after you complete the project, you can go back and do the same questionnaire again and see what improvements have been made.
And then this is, and I think we have this one in English and Spanish. And then this other one is a survey that I had created a while ago that's specific to doing a watershed assessment. So it kind of goes over the key questions that I could do this. I did like 50 of these. And you just go out in the field, ask a few people some questions, kind of walk around. In my case, we had paid a little bit of money to have some of those maps because it was worth it, so that we could delineate it from the map and then spend just even a half a day, a couple hours walking around the watershed and could get a really good assessment of that watershed to really shape the direction of the project. And so I have that form available in English and Spanish as well, if you're interested.
One of the other items is, what tools do you take? Well, if you carry a transit that weighs 35 pounds, you're not going to take it in your backpack very easily, or a tripod is really difficult to carry more than a couple miles. And so of all these tools that you see on the picture, I think one of the best and easiest ones that are very helpful is the color imagery. I'm a strong proponent of having imagery, not only using it for the community input thing, but just for walking around in people and in the field and marking it up and circling areas of where the canyon really is. Using the post-note flags, GPS unit, tape measure, with the exception of the iPhone that's up in the corner that is capable of doing GPS measurements at limiting battery life. I'll discuss accuracy in a minute, but the fact is most of these other items you can leave with the community so that they can begin to do things by themselves. Now, if you have a $600 clinometer, like the gentleman here from Austin was carrying around on his shirt at the open house, he's not likely to want to hand that to anybody and not really care where it goes. Although I left some tools on the last trip to Ecuador, and other people have done that. And so it's not much risk for what they cost at Home Depot to leave some of these tools, for they can do their own survey work.
And I'll add with the paper color imagery, the problem is if it rains, it gets all smeared. But in Honduras, where I was living, you can just buy clear contact paper for so cheap, and I would just do my own self-lamination on 11 by 17 map anytime I was going out to do surveying or any field work, and it was so hugely valuable, and it wasn't that difficult. Just 11 by 17 contact paper, and you're set.
They also commercially made good any of the sailboat or sailing, any navigation, like West Marine, they have 11 by 17 envelopes.
Oh,
You
okay.
just take their thing, you take the chart, slam it in there, seal it like a vacuum.
Cool.
So
It's handy.
you can draw on them and take your map back out.
Comment, go ahead. Another comment? Question about accuracy by GPS. Before you go on a trip, I would strongly recommend you take your GPS unit to a survey control point. There are primary, secondary, first order, second order, and third order points all over the United States where you can go to and check the accuracy of your GPS. I've done that with a camera, iPhone, 2 models of GPS units, and I believe, did I go backwards or what happened? I'm going to go back one slide. I believe the accuracy of a GPS unit is dependent on where the satellites are. So at the end of the presentation, there's some links there you can go and find out where the satellites are at different positions, and even pick a time or a date. Generally, the dates are stuck with how you your work schedule or your classroom schedule when you have to go on a trip. But you can pick the times of days or the days that you do important measurements. Horizontally, most of the units, including an iPhone, are good to about horizontally to 3 to 6 meters. Vertically, they can be off 6 to 30 meters. So if you just accept that, and I found that for the accuracy that I needed for doing most water mapping, horizontally within 3 meters is good enough. I mean, if I get a water tap within 3 meters of a person's house, once we get there, an extra 3 meters of pipe is not going to kill me. I mentioned about calibration at known points. I'd like to add one more item. Besides calibrating your GPS unit in the United States, or wherever at known survey points, you can also, when you go to an airport, every airport has an airport elevation posted somewhere in the airport elevation. Now, what that elevation is, it's the highest point of the highest point on an airfield, out in the airfield. Well, rarely do most of us have access to the airfield side. But using Google Earth, you can follow the runways of your particular place you're landing and find out the high point on that airport on the airfield, and then follow using Google Earth, find out what the in front of the terminal building is out in the open, and find out the difference in elevation between the high point in the airfield and the front of the terminal, and use that differential to calibrate your GPS unit. So before I came here, I checked out the ability of Google Earth to have the correct elevation at Dulles Airport, and using airport diagrams, I actually found out that Google Earth had the elevation of the ends of the runway within 1 foot of, actually there were 8 runways, and so they had brilliant accuracy here in Washington, D.C. I did the same thing for airports in the Andes, and in Bolivia, one was off 50 meters. Another was off, on the average, after about, I think I did 7 airports, it averaged about being 20 meters off in the true elevation. Well, the true elevation is surveyed in for these high points on the airfield because the pilots need it. But so anyway, I would say calibrate your instruments, not only here, but once you get on site. And I mentioned the item of GPS photos. There is metadata that's attached with every photo, particularly if you're using a GPS camera. And you can clip that metadata and paste it on the picture. And so even today, I can walk in and tell you exactly where this tank is and the approximate elevation, plus or minus 60 meters or 30 meters. And if you come back with a whole bunch of pictures of a whole bunch of tanks spread over the place, and you're trying to say, where did I take that picture? It's a lot easier to do it this way than to hand write down, coordinate picture number with location. Probably sort of closing, we referenced a lot of this information that was available, and here's a slide that just begins to list links where you can go to, and if you're looking for, how do different pictures look with the resolution of different pixels. And so there's a website that shows how sharp something is under a 1 meter pixel resolution or a quarter meter. There are places where you can get satellite imagery. There's information where you can get global precipitation and runoff. There's worldwide hydrogeologic mapping. There's just a source of an application of how you can get a GP. For $2 you can get a GPS unit made on your iPhone. But I would just take the measurement quickly and not leave it on for your entire exercise, or have a backup battery. Translating from geodetic to GPS coordinates.
So just in conclusion, we talked, a lot about the specifics of mapping, and I saw a lot of people trying to write certain notes, and we will make this presentation available, and that handy table with all those critical links we'll make available on both our EWB website and then specific to this conference, so don't worry about that. But hopefully another point that maybe we've made indirectly or maybe not that I'll highlight again is just the importance, just thinking about your project in a more holistic way, looking at the larger community and kind of starting big and going in and building up from that versus starting with an idea to do a rainwater catchment project and building it on this school and then just using a map to kind of orient it to help construction, I think is a more holistic way to approach the project that's very consistent with what hopefully you're learning throughout the weekend here at this conference about the importance of when you're doing international community development. You can never, it's always dangerous to just look too specifically at technical details without seeing that bigger picture. And just to help reference that, these are 3 good references that you might find useful in just understanding how to do a good job with engineering in the developing world context. So we'll leave those up as we leave time for questions. Well, actually, there's one slide. We could have questions, or we could be done and have a beer.
That's not encouraging
but we could go back to these important references. Yeah.
I just wanted to comment on the use of laser distance inclination device. I found it very useful in producing a 1-inch equal 20-foot scale site map. Very relatively inexpensive, about the same cost as that Garmin GPS unit. And our experience with the Garmin GPS unit was, in fact, what you said. We were lucky to be within 10 foot plus or minus of the actual location.
Robert?
I was going to second that. I did a lot of geomorphology work, and what we used was laser binoculars. It was essentially inclinometers hooked to at that time, the little iPad, so now it would be a pocket PC of some kind. It was every time you started your survey, and we would go over several days, you start on that same point and get your reference. And when you finished your day, you moved back to that same point. And because over the day, the satellites will obviously move, or you'll move in relationship to the satellite. And so you may be 3 meters in the morning, and you may be 30 meters in the afternoon. But at least you know how you shifted over the day. I think that it's important that as old timers always closed our survey. You never finished until you got back to your starting point. And it had to work. If you didn't get back to your same coordinates, you had to go survey back until you found your error. When you're doing it with the electronics, I think we need to do the same thing. Pick a point in the village, whatever it is, and always start and stop your survey, no matter what method you're using, on that same point, and check its accuracy.
Thanks. John?
So thank you, first of all. It's an excellent presentation. Very informative. The thing I guess I would ask, what are your recommendations about, so you go to this place, you get all the data, and then, so you have that data, and then how do you make it into a map? Like that process in between, right? Would you put it in Google Earth? Would you put it in like ArcGIS? Would Google Maps perhaps? I mean, like what are your ideas on that?
John?
Well, there's several ways of drawing maps. One of the most common ways is everybody uses AutoCAD as a drawing method. You can do it that way, which is computer-based. You can do it manually. Number one, I think all the drawings and everything in drawings ought to be to scale. So I think you can make a lot of mistakes if you don't draw something to scale. So your preference, AutoCAD is a widely used one. MicroStation by Bentley is another second common one, although the program is more expensive. Students can frequently get a student version of AutoCAD for practically very little.
It's free.
That's for all right.
That's very
A lot of the items that I even listed, like imagery, for example, is available through the geography department of your universities for free. Our chapter is a professional chapter. We had to pay for the imagery. We paid about $1,472, if I remember. And it covered, an area about 7.5 miles by 5.5 miles square, just converted back to English. But those imageries can be imported into AutoCAD or into MicroStation, or you can just print them out on paper and put a piece of tracing paper over it and draw it by hand. There's nothing wrong with drawing something by hand.
There's also, there's like the Google Earth is really popular now. A lot of people are using that because it's open source, it's free, and they have all the blogs online that they do. But and then ArcGIS, I guess that's about like MicroStation, something like that.
That's even more expensive and more complex.
Why can't we get a free one of those?
Well, you can get Google Earth Pro.
Yeah.
There's
Yeah.
Google Earth Pro that you can get for $100. So they have a new, but it's for personal use only. You can't use it for corporate use.
EWB has Google.
Get a 6-month license of ArcGIS for free.
Okay.
Yeah,
Wow.
that's right. Or I got a free. I attended the University of Colorado, and I got a free unit of ArcGIS for a year on a CD, full-blown thing, with no label saying student version only. Go ahead.
Thanks.
There's also, if you're looking for a program to just do like pump stations and like joint boxes and pipes and stuff like that, EPA-Net is a really good like point-and-click program. Very simple, very straightforward program just for doing like water layout systems.
This is not a comment on design, but I will caution you that EPA-Net, the design is based on a pressurized water system. And so if you have, in Ecuador, if you have a very steep water line and you're using a minimum pipe size, you're not able to keep the line pressurized. And so all the formulas that are generated through the EPA net do not provide consistent answers.
Our chapter is currently trying to do some work modeling, pressures and flows in a, piped water system from up on a volcano. We're wondering what type of software is out there that we can use for that, because currently we're using WaterCAD and we're having some struggles getting a good model.
There's nothing wrong with using Manning's formula and using an Excel spreadsheet. It works.
Just as an answer, watersheds is a software that our group uses, and it's free through the EWB-USA website under like chapter resources
Mm-hmm.
or something. Watersheds.
Water gems.
What? Do you know how to use that software?
There's I think it's a YouTube tutorial. I'm pretty sure the YouTube tutorials that I have to double check on that.
I think I watched the tutorial, but this is pretty cool.
Yeah, it's complicated.
Do you know if there's any other software similar to it?
If you send me an email, I'll give you a link to a website. There was a student at Boulder that created a website that listed about 15 different water use softwares for doing water systems.
Cool. We should put that on our website. Great. I think just one last question. Rachel?
Well, I had a couple of questions, I guess.
Well, we're getting kicked out
First-
in 3 minutes, so we
okay.
just.
Well, first, with the community mapping exercises, do you have any experience trying to geo-reference any, or like try to take any data from the maps that you've gotten from the communities and transfer it into a digital form or in GIS form or something like that? And
What we did do is we went to every house to do the interviews that were in the center panel. And with those interviews, when we were at a house, we used our GPS unit just to take pictures.
like trying to map the natural resources and things like that? Or is that more just to understand the landscape of the community? Or how did y'all use it?
Most of the data was used just to gather input from the community.
Okay.
Maybe confirm.
Now there is a ArcGIS has the capability of associating databases with places, and so that goes up a layer in complexity, and that's a very difficult program to learn, and it's unless you get a free cut from the university, which you can get.
Like georeferencing images? Is that what you're talking about, or not?
Well,
following you?
the references are all georeferenced to the same place if you follow the standards.
Right.
And everybody uses the same standard. We shared our standard with some geologists, and they've got a map from somewhere else, and they said the imagery matched completely with the geologic survey they did of the area. So if you're using a common standard, then it gets georeferenced automatically, because when you pull a drawing into AutoCAD, for example, it gets georeferenced. So the imagery that you see has a database metadata associated with it that locates the imagery to a coordinate system. So that's built into the purchase. When you purchase imagery, you want it georeferenced.
So we can continue discussing out here, but I think we are getting kicked out right now. So thank you.
Okay.